Hello students, the purpose of this video is to go through section R, A inside of chapter R to ensure that you feel good working with inequalities as well as absolute value inequalities. So we're going to start by working on solving inequality problems, and I want to note that you're going to treat these just as you would any other equation. So your book in this section actually provides a list of 6 different properties. However, there's really not a need for us to talk about these because the rules are simply showing you that working with an inequality is just like working with an equation. So, for example, if you were trying to solve for x, you'd want to get your x on one side, everything else on the other, and you literally solve as if there were an equal sign. The only difference is there's an inequality. The only thing that you must remember is that if you divide by a negative, you have to flip the sign. So that can be the tricky part that some people forget. That is different because you are considering the inequality sign. So anytime you divide by a negative, you must flip that sign. So there's 3 different notations and ways that will represent the information we're looking at. We'll be looking at equation inequality form. So if it's an equation, it's going to have the equal sign. If it's an inequality, you'll have your inequality symbol. We can represent our solutions in solution set. So you see here I've included a roster method solution. I've also included set builder notation. I also want to note that we can use interval notation when talking about solution set. And then the very last representation and notation we'll utilize is graphing on a number line. So we'll use a combination of our open and closed circles and shading in our number line to represent the solution set. So I have an example here. We have 5x minus 7 is greater than 3x plus 9. And so you want to be able to write this in symbolic form, interval notation, as well as show the solution on a number line. So our first goal is going to be to get all of our variables on one side and then get our number solutions on the other side. So I have my 5x and I have my 3x. I'm going to put those on one side. And then I have my negative 7 and my positive 9, and I want to get those on one side. So I'm going to go ahead and leave 5x where it's at and subtract 3x on over. And then I'm going to add my 7 on over. 5 minus 3x is 2x, and 9 plus 7 is 16. And I'm going to divide by a positive 2, so I don't need to switch my sign. And that leaves me with x is greater than 8. So this right here is your symbolic form. So you want to make sure you feel comfortable putting that in its inequality format. You then want to be able to answer in interval notation. So considering what is your lower bound and then your upper bound. It's important that you always put your lower bound first and then your upper bound. It's actually incorrect if you do it the other way around. So you want to be really, really careful with that. In this case, my lower bound is 8. It is not included because my inequality sign does not have the and or equal to symbol. So I'm using a parentheses. And then x is greater, so that means I'm headed toward infinity. And then for a number line, I'm going to create a number line, and I'm going to mark the value 8. I'm going to utilize an open circle because I'm not and or equal to, I'm just greater than. And I'm looking at values bigger than 8, so I'm going to shade to the right. Okay, so those are the 3 formats that I'll be looking for you to put your answers in. So here's another example, literally the same exact situation. You'll notice I have a number on one side, a plain number on the other side. I have a term with x on one side and a term with x on the other side. The only difference here is I included a term with the fraction. And so that's to get you comfortable working with the fraction or telling you, or reminding you, I should say, that you can start by getting rid of the fraction. So remember, I've taught you a process of multiplying out your denominators. So if I multiply this thing by 2, the 2 in the denominator cancels out, but then that means every single term needs to get multiplied by 2. So 1 times 2 is 2 minus the 3x is greater than or equal to 2x and then minus 8. Again, that's because I've been multiplying 2 to every term. And now I'm going to get my x's on one side and my numbers on the other. So I'm going to leave the 2 and add the 8 on over. And then I am going to add my 3x on over. 2 plus 8 is 10, which is greater than or equal to 5x. And when I divide, I end up getting left with 2 is greater than or equal to x. So that would be my symbolic notation. If I wanted to put the solution in interval notation, my lower bound is x, so that's actually headed toward negative infinity with an upper bound of 2. But 2 is going to get a bracket since I have the and or equal symbol, and then infinity will have my parentheses. And then the last thing I want to do is create my number line. So I'm going to mark my value of 2. And I care actually what is happening on 2 according to the inequality that I have. And I'm looking at values smaller than 2, so I'm going to shade to the left.